let's talk about question 23 now. So we say we have when the mean, median, and mode of the list 10, 2, 5, 2, 4, 2x, when they're arranged in increasing order, they form a non-constant arithmetic progression. And we want to know what is the sum of all possible real values of x. So let's like remind ourselves like what is an arithmetic progression, right? So an arithmetic progression, if you have like three numbers, in this case, we have the mean, median, and mode. So that's three numbers. So when three numbers form an arithmetic progression, what that means is that like the numbers, like they have a common difference. Remember, like we talked about before, like for example, the numbers like, 5, 10, 15 form an arithmetic progression because each time we add 5. So like the difference between consecutive terms is always constant. Similarly, like 100, 200, 300, that's like an arithmetic progression, right? So yeah, so to solve this question, we have the set of values 10, 2, 5, 2, 4, 2x. So for these, this is also like an extremely common type of question. And usually the first thing you want to do is you want to arrange these numbers in like sorted order. So if we were to sort these numbers, right, sort the numbers from smallest to largest, I can write them as like 2, 2, 2, 4, 5, 10. And to be honest, like x, I don't know what x is going to be. Like x is like a variable. I don't know if x is a really small number or if x is a really large number. So I don't really know where to put x right now, but let's just like put x like at the very end for now. And so first of all, let's calculate what is the mean of like the set of 7 numbers, right? So to calculate the mean is basically like the average of the 7 numbers, right? So if we were to do 2 plus 2 plus, so we have that the mean is equal to the 2 plus 2 plus 2 plus 4 plus 5 plus 10 plus x divided by 7. So if we were to like simplify the top, 2 plus 2 plus 2 plus 4 plus 5 plus 10, that equals 29. So we would have x plus, actually that equals 25. 2 plus 2 plus 2 plus 4 plus 5 plus 10 is 25. So we have x plus 25 divided by 7 is equal to the mean of the 7 numbers. Now let's also calculate what is like the mode of these 7 numbers, right? So the mode in a set of numbers is like, in case you don't know, like the mode is basically like the most common number. So like in this case, clearly 2 is going to be the mode, right? Because 2 appears like the most often. So we have that the mode is equal to 2. And the median but the hard part here is calculating what is the median. And the reason the median is like kind of hard to calculate is because we don't know where x, like how large x is, right? So like for example, if x is really, really large, right? Let's say x is really large, then in this case, like the median is like the middle number, right? So the middle number, if x is really large, the middle number is going to be 4. So in that case, the median is going to be 4. So let's first calculate this case, right? When the median is equal to 4. So we have these 3 numbers, and we know they have to form like an arithmetic progression. So basically like notice that like if these numbers form an arithmetic progression, then we can have like the mode is 2, the median is 4, and the mean is x plus 25 divided by 7. So if these numbers are to form like an arithmetic progression, then like this number here has to be a 6, right? This number has to be 6 because 2, 4, 6 forms like an arithmetic progression. So if we were to have x plus 25 over 7, if this equals 6, then solving for x, we would get x equals like 17. And the reason this works is if you put back x equals 17, like you can like kind of like check it and verify it, and you find that x equals 17 does work. So x equals 17 is a solution. But like we have to be careful, right? We can't just say the answer is x equals 17 and just put down like D and like move on. The reason we can't do that is because like there might be other possible values of x as well. So we can't just like kind of do that. You might also think like, oh, remember this is like not the only possible way to arrange the values, right? Like maybe the 3 values are in the form like 2 x plus 25 over 7 and then 4, right? This is also a possible like arrangement, and we could have this middle term here. We could have it equal to 3, right? Because 2, 3, 4 also forms an arithmetic progression. But the reason this doesn't work is because like if you're to set x plus 25 over 7 to equal to 3, then you can solve the equation, you get x equals -4. But like if x is -4, the reason that doesn't work is because then like here, this value of x would be -4. But then we assumed if 4 was the median, then x is going to be the largest number in the data set, right? But like clearly if x is -4, then x should belong over here, -4. And then the median would no longer be 4. The median would be like 2 now. And that's why like -4 doesn't work. So that's why you have to be like really careful. Yeah, and similarly, like you can use a similar logic and find that like if you have x plus 25 over 7, 2, 4, right? This is also a possibility. And if this is equal to 0, like 0, 2, 4 also forms an arithmetic progression, then you get x is -25. And using similar reasoning, this also doesn't work. So now like we have like a few more cases to consider. Like the next case is like if x is like a really small number, right? So here we assumed x is a really like large number, but like we might also have the case. So we have 2, 2, 2, 4, 5, 10. Those are their numbers. Maybe x is a really small number. So x is all the way is the smallest number in the data set. So x is all the way at the end. So in this case, the median is going to be 2 instead of 4. So the median is 2. The mode doesn't change. The mode is also 2. And the mean, we already calculated, the mean also doesn't change. It's x plus 25 over 7. But luckily, we can just kind of immediately disregard this case. And the reason is because if the median and the mode are both equal to 2, then the mean must also be equal to 2 in order for these things to form an arithmetic sequence. But if all of them are equal to 2, we have to look back carefully at the question. The question said they form a non-constant arithmetic progression. So non-constant means like the values cannot be constant. But if we have all three values equal to 2, 2, 2, 2, that's like a constant sequence, that violates the non-constant condition. So we can like kind of cross out this like case here and just like disregard it. So then we might be like, oh, we might have covered all the cases. So the answer must be like 17, right? Which was the only value we found, x equals 17. Here, let me like circle it in red. But like we have to be like extremely careful because it turns out like we have one last case, which is when we have the numbers 2, 2, 2, 4, 5, 10. It's also possible that like x is the median of the data set, right? So we could have x as the middle number. So we have to be like very careful here. In this case, the median would be equal to x, since x is the middle number. And the mode is still equal to 2. And the mean is going to be equal to, still equal to x plus 25 divided by 7. So if these three values are to form an arithmetic progression, we can kind of do some trial and error. So clearly, this number here, if we were to like kind of like do some trial and error, we can kind of see if we have 2 x plus 25 over 7 and x. I think actually maybe the easiest way, instead of like solving the equation, maybe an easier way is to go back to the original thing here. Like we have this sequence, right? If x is the middle number, then x has to equal either 2, 3, or 4, right? Because if x was like any other value, then x would no longer be the median. So we can kind of test these values one by one, right? So if x equals 2, right, then here you'd have 2, here you'd have 2, here you'd have 27 over 7. Clearly, these three values don't form an arithmetic progression, so x equals 2 is not a solution. So now, like, let's try x equals 3. So if x is 3, the mode is 2, and the mean is going to be 3 plus 25, which is 28, divided by 7, which is 4. And we see 2, 3, 4. Indeed, they do form an arithmetic progression. So that tells us that x equals 3 is actually a solution as well. And our last case is when like x equals 4. So when x equals 4, if x equals 4, then we have the median is 4, the mode is 2, and the mean is going to be 29 over 7. And you can pretty easily see that's obviously not an arithmetic progression. So in this case, we found that x equals 3 worked. X equals 3 was a solution. And we also found, so we have x equals 3 as a solution. And we also found that in a previous case that x equals 17 is also a solution. So if we want to find the sum of all values of x that work, we would do 17 plus 3. And we go back to our answer choices, and that would give us choice E, which is 20. Okay. Yeah, so just to like quickly summarize again, this is like a very common type of question where they might like give you a set of numbers and they tell you the mean, median, and mode, maybe sometimes the range as well. Maybe they have satisfy some interesting property. Like in this case, we're told they satisfy the property that they form an arithmetic progression. And a lot of the times in these questions, the median, which is the middle number, is often like kind of like the troublemaker, right? Because we don't know which one is going to be the median in this case. Like depending on x, if x is really large or if x is really small, or maybe x is like right in the middle, the median will change. But notice that the mean is always x plus 25 over 7. The mode is always equal to 2. So we kind of did like casework on how large the value of x was. So like if x was like the largest number, then we kind of like did these cases and we like split it case by case. And we did another case when x was the smallest number, and we did another case when x was the median itself. And those were like the 3 cases that we had to consider.